I think it's fine to be like, ooh, we shouldn't teach calculus in high schools because it's like, there's like a shortage of U.S. production of people that can teach calculus, which is like true in the United States, right? And I think it's fine to be like, oh, you can teach like a lot of the sciences without calculus. And it's like, oh, we're going to do science now. It's like, once you're doing science, you like have to be able to do the calculus. And generally speaking, you have to be able to do differential equations and multivariable. Now, you don't have to know how to do that stuff manually. You can take this class. But like I don't know what the alternative is, right? So like, I mean, one of the reasons I never learned symbolic computation is like I just could take integrals, so I didn't have to, right? But like, was that like a super useful thing for me to learn how to take integrals? Like, no, and I made mistakes, right? So it was much better once I could start doing it computationally. Speaking of derivatives, let's take a derivative. Does anyone want to take a derivative? Oh, yes, you do. That was a leading question. Okay. Wait, no, I got it. I'm going to bring it back. Oh, instead of taking a derivative, you can have the computer take the derivatives. Okay, all right, there we go. That's what I meant. Import SymPy. Okay. We imported SymPy, right? What am I going to do? I need to make x something. X is currently not anything. So I'm going to make x a variable, a SymPy variable, or perhaps a SymPy symbol. It is also going to be a Python variable of the same name. That's kind of weird, right? But I'm going to say x equals SymPy dot symbols x. Now, you can do this, and that's crazy. So just don't do it. It'll cause your brain to explode, okay? Just do this one. It's fine. It can't hurt you. Okay. Right. So, and then we can create some function. I don't know. F. X times x. And so that's x squared, right? And then we can take the derivative of that. I think diff here stands for like
differentiation.
That's it. I could not remember that word, so thank you. Differentiation, right? Okay, got it. Diff. And I think we can't necessarily just do diff, though maybe you can, right? By convention, you'll specify what you're differentiating with respect to. So, for example, if I were to differentiate this with respect to y, like nothing really happens, right? So, this is how you take derivatives. Okay, who has like a complicated thing we should take a derivative of? I'll just start typing stuff and we'll see what happens. Okay, so we can do a diff of like, maybe we take x times like x minus 7 plus like x squared plus x divided by x to the third. I don't know. Does that look hard?
Sure.
That wasn't that bad, right? Like, the computer figured it out. Would I have ever figured that out? I mean, probably someday, but like not quickly. And then, so we can also create y equals symbol SymPy dot symbols of y. Nope. Okay, there we go. And say we have like x times y. Well, we can also take the derivative of that. And maybe this will be a little more fun if we do like f equals x plus y cubed. That's like relatively complicated, I think, right? Maybe I can like factor that or something. I don't know. SymPy dot simplify f. Yeah, maybe factor. I don't know. Okay, so we got our equation. And we can SymPy, yeah, bless you, f with respect to x or with respect to y. Oh, it's the same thing because I did the same. Let's see. Let's do a different f. Maybe if I throw a negative in here, this will be different. There we go. So if I have a negative y the derivative is in like some different direction or something, I think. I don't really know how multivariable calculus works, but I guess it's something like this. And I think I can also do this. Is it subs?
Yeah.
Y7. So also if you like happen to replace the y with some static value, you can still do the same calculation. And this also shows a really fundamental result in multivariable calculus, which is that you can just differentiate with respect to one variable at a time, which is really important if you're studying the Krebs cycle and you have rates of change of different reactions. You can separate them out and study them differently unless they're functions of each other. And I think we can also we can multiply differentiate this. Well, let's see, what's that? Okay. I guess I'll call this the derivative with respect to x. There's dx. And I think I can do simpi dot diff dx with respect to y. And I can get the derivative in two different dimensions at the same time. This is a lot easier if you can visualize it, which seems like a lot of work. So I wasn't going to do that right now. Well, it's multiple dimensions, right? So there's no graceful way to visualize it. I'd have to make like project an image of a surface in 3 space or something, right? There's also integrals. I heard someone in here really loves integrals. Yeah, okay.
Depends on the integral.
What's your favorite integral?
I kind of enjoy the ones where I get to use USUM.
Okay. I don't know what that means, because I was going to type something into the computer.
For an integral, maybe... Oh, yeah, that's a good one.
All right, well, fortunately I happen to have that one on this slide here, so I don't even have to type anything. Wow! Wow, look at that. You see that? The integral of sine is negative cosine, which I think I learned in a class at some point, so I guess I believe that, right? And then, of course, the really fun thing to do is that if you take the derivative of the integral, you get back the original thing. So that's kind of neat. Or maybe it is. But if we say, for example, what is f of x currently? Okay, so if we... okay, I'm tired of typing simpi dot every time, so I'm going to type from simpi import star, and it's going to put everything from simpi directly in my namespace, okay? This is going to break a ton of stuff. Okay, so I'm going to say diff of integrate of f. Oh yeah, that did explode. Okay. That seems reasonable. Dang, I really wanted that to work. Integrate f x. We're back. Okay, import simpi. Okay, so we'll take f of so let's see, x equals simpi dot symbols x, f of x, f equals, I don't know, simpi dot cosine of x. And then if we do simpi dot integrate f, we get sine. If we de-integrate, we get negative sine. But if we integrate, then differentiate, we get cosine back. And if we differentiate and then integrate, we get cosine back. And this is known as the fundamental theorem of calculus. So you all know calculus now. Did you all know calculus before?
Yeah.
But now you like double know it. You know it like more than you used to.
Is when I learned AP calculus. I think my teacher didn't teach me calculus in the same year. They just assumed that I remember from 11th grade.
I really have to stop typing.
and that's how I followed my BP math.
Okay. Commonly, when taking integrals, you don't take the indefinite integral, which is expressed as a formula, but you take the definite integral, which is the area under a curve in a certain location. And so one way to do this is by specifying a domain for your integration, which I'm going to demonstrate with exponentiation. Is there already an e in here? No. From Skippy import e. Okay. So there's a few ways to do e. I think I can say e to the x, or I can say simpi.x and get, I think these are probably the same thing. So we're going to integrate these. So we will simpi.integrate simpi.exponentiate x. And we can see that the exponentiation is its own derivative or integral, right? Because the integral is the antiderivative, right? So these are in the same direction. Okay. And then we can specify that we're doing that with respect to x, but we can also say, hey, we want to do that for x in the range 0 to 1. And that will give us 1 plus e. Oh, is that e? Is simpi just has capital E? Oh, that's, I wish I knew that. Okay. And then we can do the same thing here with simpi.e to the power x, and it will come out the same way. So this is one way we can integrate things, and that is the area under the curve of the exponential. Integral of x from 0 to 1. It probably won't explode. And so my claim is the way we did this was cooler than typing it into a formula. You're going to make me visualize it? Okay, all right. All right, break out the matplotlib. I didn't actually have a plan for this.
Sorry, for this in the parentheses x01, the second and third argument is the
Start and
domain.
stop, yeah.
Domain of the. Okay. So now it's like indefinite integral instead of
Correct.
in.
Indefinite, yeah.
Okay.
Yeah, I don't know how I figured that out, because it doesn't seem to be written down here anywhere. Oh, no, there it is. Yeah. There it is. Great. Okay, so import matplotlib.pyplot as plt. Did I already import numpy? I don't know. Okay, what do you want me to do?
Graph
Graph what?
the integral.
The integral, definite integral of.
Okay, I'm going to plot the function, and then we'll discuss what we mean by plotting the...
Okay.
Okay. Okay, so we'll create a... from 0 to 1 specifically?
Yeah.
So we're going to say x is equals np.linspace 0, 1. That looks fine? Okay. And then we're going to say y is equals... Plot the equation?
Yes.
Okay, so we're going to say f equals exp of x, right? No, it's simpi.x. So we want to plot this thing, but we have to lambdify it. So we say simpi.lambdify f. With respect to x. Okay, first try. And we're just going to say that's f now. Okay. Easy. What is f of 1? X? No way. 2? Okay, we did something wrong. Okay, so this is SymPy lambda phi. Yeah, I'm gonna start over
I
again
was
just a
gonna say,
little
now
bit.
the F is, yeah.
Yeah, well, it didn't seem to be being what I wanted it to be. Okay, so maybe this is an equation, and we're going to apply this to 7 and see what happens. Oh my goodness. Why are you making me do so much work? Why is it giving x back? Okay.
Maybe we should exit Python and then come back into just
I think we should just figure it out. Okay, I appreciate your lack of confidence in me, which I share, but I'm just gonna go for it.
Could it be because X is still a symbol?
Oh, it's because I did them in the wrong order, I think. That's crazy that that's what's wrong. Okay. Yeah, so I just did it wrong. I was okay. Sorry. Honk honk. I was a silly goose. Okay. All right. Wow, that was strange even for me. Okay. So f of x is okay. All right. So we can plot that. How do you plot things?
But yeah.
Seems fine, right?
C.
Is this gonna work? Okay. So you're allowed to do that now because you're grown-ups. You weren't allowed to do that before. Now you know. Okay.
Grown-ups.
Yeah. Now that you're adults. Okay.
So
Why does
now-
it go to 50?
That's a good question.
Is it because you didn't write down like the domain very long?
Yeah, I think so. Is this gonna work? Is that what we wanted?
Yeah.
Okay. So that's okay. And then what is the other thing that we wanted?
We want to
'Cause-
shade in under the curve.
Yeah.
I don't know how to do that, but
is this not how you would check? Fill between. Okay. All right. So we're gonna. Okay. No, I have a plan. Okay. Did it close? What is happening? It's still open. It's gone rogue. Okay. So we got plot. I'm gonna plot cla. We're gonna do clear everything or something. I don't know what it stands for. Yeah. Okay. All right. So our plan is to become geniuses. Fill between. Okay. So we're gonna plot x's and f of x's, right?
right.
And then we're also gonna plot 0. Is that for real? Ugh. Okay. Not to worry, I have a plan. I'm going to write a function that takes any input value and returns 0. I will call it g. Okay. So we're going to do g of x's. Really? This didn't work? Oh, it only gives 1 0. Because it's not vectorized. X's to wait, no. Oh, I have an idea. Okay. X's times 0? No, that was an O. Okay, there's a bunch of zeros. I got a bunch of zeros. Okay. I think I also could have said like np.zeros 700 or something, but I didn't actually check how long my linspace was, and I was too embarrassed to look. It was 50. Okay. So there was maybe a much easier way to do this than the way I did it, but the way I did it is cool and fun. Okay, so we're gonna plot fill between. I have no idea what this is gonna do. F of x's and 0 times x's. Nope, not even close, right? Simple shade between method. What's this do? Oh, that's what we wanted.
There
Okay.
we go.
All right. Okay. Claw. Okay. All right. We'll start over again. Okay. From import matplotlib dot pyplot as plt. Import numpy. I'm no longer import as mp. I'm no longer using simpy at all because I'm just plotting things. So like I don't really know what you want me to do. So we're going to say x's is going to be an np.linspace from 0 to 1. And then we are going to plot.fill between x's and then np.e to the x's, I think. And then we're going to plot show.
Wow. Now we're just as cool.
Okay. And I think showing is cringe, so we're going to plot savefig as int grail dot hung. We'll use an SVG. And then we'll os dot system open or start. Why did I spell it like that? Now I have to type it again. Ooh. Oh.
Huh.
Oh, I bet plot.show consumed it. I have a plan. Oh my gosh. I'm allergic to failure. Sorry, was that a little too metal? Okay. Simply don't fail. First try. First try. Okay, you asked for all this. Now what did you want to do with it?
No,
Just wanted to look at it.
You just wanted to look at it.
just wanted to know how to do that.
All right.
We did it.
Now we graphed a definite definite integral.
Yeah. What do you think the area of that thing is?
Oh my god.
That's a good
Depends on what
question.
units.
Should you find out?
Oh, I mean, I can, but we already know it's E-1 because we checked.
That's true, we did check.
We did check. That would be a lot of typing. Okay, we'll do it again. Import simpy. X equals simpy dot symbols x. F equals p dot e the x. Simpy dot integrate. I don't know why I defined f. I didn't have to do that.
And then
Is that what you wanted?
I don't know.
You don't know what you wanted. I'm trying to give the people what they want. The mob is so fickle, you know. This is probably why they got all those pitchforks and killed Dr. Frankenstein. I think about that a lot while I was getting my doctorate. I was like, I don't want to be pitchforked. Oh, yes, these are the same things.
The doctor or the monster?
I don't actually remember which one they were pitchforking.
Wasn't it Dracula?
I don't think they pitchforked either of them.
Yeah.
Well, not in the original series, but in Van Helsing they went after one of
I
them.
feel like it was the
It
monster.
would probably be the monster.
But isn't Dr. Frankenstein really the monster?
Well, that's
He
arguable.
is. Yeah.
I would say it's the monster and the creature is how I would describe them. But you know, you can do whatever you want. You're adults. Is that not true? Are you not adults? Are you not of legal voting age?
It's true.
Yeah.
What was the difference between doing simpy x? I mean, dot p x p in the parentheses x and then what we did earlier.
This one?
Yeah.
This earlier one?
Between that and then the one on the bottom.
So this is not a symbolic e. This is a literal e. So np.e is a number, and simpy.e is a symbol. So this this is the symbolic computation we were talking about. This is an approximate result because it uses an approximation of E. And this is an exact result because it preserves the E. So this is correct. This is wrong.
It's not wrong, it's rounded.
It's just not as precise.
Well, I mean, here's an easy way to check if it's wrong, right? So we determine ground truth by using symbolic computation, and we check to see if it's equal. Integrate. They should call it integrate because it's great. NP.E to the x, x, 0, 1. It's wrong.
It's not equal.
Yes, but so this is not equal to the correct answer.
Yeah.
So yes, NP.E is the literal. I mean, the rounded.
Mm-hmm. Yeah. There's NP.E and there's probably also a.
SymPy. That one is like is the actual symbol E.
Yeah. So these are numbers, and the
So, for
the
example,
SymPy one
if
is.
you wanted to, if you wanted to do pi, it would be SymPy not pi. Or something?
Mhm. Probably. I don't know if it's capital or lowercase. Yeah. And I think I can like get some digits.
Those are some digits.
Yeah. So when someone asks you for your digits, you got to give them this, right? You got to hit them with the SymPy of LF, right? And we can do the same thing with E. And I know some people said the computer's not wrong. Ooh, oh, it is. It is. NumPy canceled. Friendship with NumPy
But
ended.
if you set it to however many digits are in the, yeah.
That's why SymPy is superior
Okay, so you want me to do
to NumPy.
this?
No, I want you to set the eval to however many digits that the NumPy has.
E? Let's see. Is that 12? That's 7. It's 13 maybe? Apparently not. Apparently I cannot count. I'm not even close to being able to count. What am I doing?
It's 16.
It's 16? I kept looking at the previous ones. Okay.
What?
Whoa, even
Yeah, there's rounding. It's not being shown. Yeah. Which I think this is extremely degenerate. For me, I should specify. Even for me, this is extremely degenerate. You can use a format string to specify a large number of decimal values, I think. Addie, let me know if you're following along. You know if this is going to work or not. So you can print out many more digits by asking for a string of long length. So that's actually much more precise than advertised, right? So you actually have this many digits. What was it? SymPy.e.evalf. I think that's like 30 or something. Maybe it's 50? How many is it? 70? Too many. Why did I skip 60? And then, sorry, I have to see what E is. Okay, so I need... Wait, these are just completely different numbers. So the calculation gets wrong at some point. So, right. NP.E is in fact incorrect because all of these decimals are wrong. It's just wrong.
The computers are failing.
No, the computer's fine. It's us. We're failing the computer by using NumPy instead of SymPy. And so what is the lesson? Don't be numb, always simp, right? Okay.
The lesson is SymPy is superior.
Yep. Okay, one famous problem is to compute the value of the following function as it approaches 0. Were you ever assigned this in any of your calculus classes, right?
Yeah.
Not to where I have a plan. I'm gonna make the equation. We'll call it F. Is SymPy sin. There we go. Easy, right? And we're just gonna take the limit as the equation approaches 0 with respect to x. Oh, I called it f, so that was a lot easier than whatever I had to do in my math class. I'll say that.
They just straight up gave us the formula for that. They were like, hey guys, it's always 1.
Just-
It's this specific equation.
Just never try. Never try new things is what I learned. Okay. We can create a printable limit object that can be evaluated. Okay, so I'm going to capitalize. We all love capitalism, don't we, folks? Right? Okay, so that's fine. We're going to do it. And what is this? This is definite versus indefinite limits. And I believe we can do this with integrals as well. Do you have any integrals in here?
Professor?
Mm-hmm.
What does the plus sign indicate? What is the
Oh, you're approaching from the positive direction, which is probably just the default. What happens if I put a big I here? Integral? Okay, so you can also have an indefinite integral, I guess. That seems cool. I don't know. I don't know what that does. It's psi of x. I don't know what that means.
I don't know what that means either.
Well, let's keep going. Solutions. Okay. The Python package SymPy can symbolically solve equations, differential equations, linear equations, nonlinear equations, matrix problems, inequalities, Diophantine equations, which is, if you haven't heard that before, that means polynomials. And evaluate integrals. It can also solve things numerically. I'm introducing a new way to get variable names. From sympy.abc, you import the variable names you want. Maybe you like that better. This is equivalent to sympy.symbol x, y. I think these are the same thing. No, stop. I think these are the same thing. No, stop. First try. It's remarkable how often I get things right on the first try. I don't know that it's ever taken me a second try.
That's very impressive.
It helps when you start at 0 and don't increase the count until you get it. Okay, so we're going to solve the following. We can solve something harder if you want. Do you want to solve something harder?
No.
You're not solving it, the computer is. Okay, so I'm going to set my equation equal to x times x minus y. And that's what I'm going to solve for, okay? Then I'm going to look at my x, and so this is where x squared equals y. Does that make sense? Just say n equals 0. You don't have to do that. You can say, please, I wish my keyboard knew what I intended. Okay, you can also do big eq x times x, y. So you can also do this. I think that looks uggo, so I didn't do it. But you're allowed to do that if you want. So anyways, back to this one. Okay. All right. Let's hit it with a solve-a-rooney, wouldn't you say? You all want to solve this?
Yeah.
Okay, fine. We'll say. That one was involuntary. I used my filter on the first one. Oh my god, okay, I have a story that is not appropriate, so never repeat it. So, we had a faculty meeting on Friday, and one of the faculty wasn't there because this faculty member was getting leg surgery, and I said break a leg to this person, and don't do that, okay? But it was real funny. And everyone understood why I was unable to resist saying that, so I didn't get in that much trouble, more than I normally do. Okay, sympy.solve eq. What am I solving it with respect to? Well, I can solve it with respect to either variable, actually. So you can solve it with respect to x or y. And I think that's kind of cool. And this would naturally suggest something to us, right? This would suggest something to us so devious that perhaps we should not even think about doing it, which is that we can probably plot this thing, huh?
You probably can.
Even though there's going to be 2 lines. Does that sound like it's allowed? Should we be allowed to do that? Well, I fear neither death nor pain, so let's go ahead and let's hit it. Okay. So we're going to call this thing f. We're gonna, why do I call everything f? Okay, we're gonna set g equals to simpy dot lambdify. Lambdify do, lambdify don't. Okay, f with respect to x, I guess? That's invalid syntax? Huh. I got this to work the other day. Does it just suddenly work when I use NumPy? I don't know. Dang. Okay. Well, I don't know how to do it. That's not true. I have other slides where I solve this problem. Okay. Okay, here it is. So how'd I do this? This looks fine, right? And all of those things worked. So all I need to do is change this. Okay, I have an ingenious plan. NVim. We're gonna make a file, and that way we can change the file and not have to type in everything at once. We're gonna call it sim.py. That's crazy. We're not gonna call it that. G.py. Okay, so sorry, my knee hurts. Okay. Oh my gosh. Okay. The thing we were trying to do was x times x times x and y. Okay. For y is the simpy.solve of curve I. Okay. And then we don't know what that line means, so we're not going to do that. Okay. So let's go ahead and print f of x, and then we'll take a look at that and go from there. Python g.py. Oh, that was slow. Did y'all notice that was slow?
Did notice there's a delay.
That was, oh, that's reasonable.
There's a lot of stuff there.
Wait, why is there that much stuff? No, stop. Oh, I threw a 1,000 in here instead of 50. Okay.
That would explain it.
That's faster. Okay. Okay, so we want to plot this. So we'll do plt.plot. This has got to be x's, plural. That's crazy. I was using x for two things. X's and then f of x's. Let's see if that's allowed. Oh! Oh no, do you see this? X and y must have the same number of first dimensions, but they're different shapes. They're different shapes and sizes. Why are they different shapes and sizes? Because there's two square roots. There's the positive and the negative. So I have to do something so ingenious, no one has ever thought of it before, except me, right now, right here in front of all of you, at this very moment, with no preparation, and I in fact didn't even look up how to solve this exact problem. That's actually true, I did figure out how to solve it. Okay, so I think there's more than one thing in f of x. For, I don't know, sine in f of x's, which is either going to be positive or negative, we're going to plot the sine, maybe? Oh my gosh, it worked.
There's no error.
Which means it's fine. Okay, so let's go ahead and show our work now. Let's see. So how do I get this thing? I'm gonna plot.savefig the g.svg. No, it's right there. Let's see. Open g. It's not opening. Firefox g.svg.
Do you have to be out of Python? You have to use like the, oh, never mind.
Oh, I wasn't in Python. Okay, here it is. Is that what I tried to do? That seems fine, right?
Yeah, I think so.
Okay, let's plot the other one. I don't really know what I was trying to do. Let's do the other way. I'm just going to change this to x and y squared. I'm going to python g.py. Invalid value encountered in square root. That doesn't affect me at all. Okay. Firefox g.svg. And there you have positive and negative on a square root. So I would probably describe this as maybe the coolest thing that anyone has ever done ever. Is that... I might have already used that this
I
term.
think you definitely did.
Yeah, you said that for, I forgot.
I don't know.
I say that quite often. Okay. There's fractions.
Wait, do you have to shade
Do I have to shade this?
in the graph? I don't know how integrals work.
I don't think that matters. I think we can do it regardless of whether it's an integral or not.
This was just on equation.
You're trying to not have fun. I heard you over there.
Wow.
Yeah,
I like that.
that's good. Anyways, here's how it's made. It's not that much, right?
It's not. It's not.
Okay. Well, we did the thing. There's rational numbers. I don't know if we care about these. The rational numbers are fractions. Sometimes it's nice to have those because there's this issue. I think I have pointed out previously that 1 divided by 10 plus 2 divided by 10 doesn't equal 3 divided by 10 in Python, right? That's kind of weird. If we go over to SymPy, we have a lot more typing. But I think this will start working all of a sudden. Oh no. I kind of thought that one would work. Is that for real? Wait.
Whoa, that's drastically different.
Yeah.
Make it a symbol? No.
We did something silly. What? Huh. I feel like I've done something wrong. Huh. This is one of the strangest things. Well, let's see, does like 3/10 work? Does 10/3 work? Nothing works.
Yeah, I don't know what those numbers mean.
I have a plan. This time it will work. It's probably not going to work. All right. So don't use that. Okay. Printing. I have been typesetting equations on these slides for many a month. Better? Okay, whose job was it to remind me of that? It was you, wasn't it?
Maybe.
Okay, alright. Is this your first time being canceled, or have you gotten through it before? Okay. Then it shouldn't be a problem. Okay. We're going to destroy all evidence of us not understanding whatever that thing was that we just didn't understand, which probably isn't a problem. Okay. Going to just introduce a tiny bit of LaTeX.
I degree in latex.
Yeah, there's not like widespread agreement. Excuse me. Import SymPy. X. Yeah, let's just do from simpy.abc import xyz. Okay. Gonna grab some symbols. Gonna create an equation. Simpy dot eq x times x and y. And what that just means is those two things are equal to each other. I'm going to set that equal to f. Okay, so there's my equation. Then I can simpy.init printing. This is going to cause Simpy to try and represent things the way I would maybe expect them to look in like a math textbook, or perhaps a biology textbook that includes the differential equations that govern the Krebs cycle, which we are all extremely interested in, right?
Right.
Yes, we are. And so then we'll put some effort into stylizing things. So we kicked an x squared up here to the higher line. We have an equal sign instead of saying eq. And we say equal to y. So maybe that's cool.
I was like, why is there 2 in the middle of that?
Yeah, so I don't actually think this is more clear, but it's available to us. There are many ways of visualizing things in SymPy, and they correspond to industry standards. MathML is what I'm using in the browser to display things. So this is MathML. When I type equations to put them on the computer, I use LaTeX. I don't use any of these. And this is what I use to make diagrams. So I haven't shown a lot of diagrams in this class, but that's what I use. So these ones are the good ones. But let's step through them quickly. We're going to use an integral example. So I'm going to go ahead and define this integral. I'm going to define it. I'm going to call it I. And let's take a look at I.
Oh, wow.
Yeah, it's kind of cool, right?
Yeah.
Like that's not bad. Like I could complain about that, but I'm not going to, right? So we can also take the string representation of I, and it will do it this way. When is this useful? I think you can throw that straight in Wolfram Alpha if you want to. And also, this is very close. So I think I can't just type this into Python, but if I say simpy.integral, ooh, wait, no, from simpy import star, this will not break everything. Then I can do it, okay? So that's, kind of neat. And then if I say I, and then I say stir of I, and then I just take that and put it in Python. Because if I take this and put it in Python, it's like not code. That's right. That was bad, right? Don't do that. Do this, okay? SREPR, which I call the string representation, is extremely precise. Is it always useful to have this much stuff, right? So if this is what I looks like, I don't know.
When would you want that?
Probably, this is another one, like if I'm putting it into Wolfram Alpha, right?
Mm-hmm.
I don't know. I haven't used this. Right. I used it once, and I couldn't tell the order of operations on something. And if you count the parens in this, it tells you the order of operations. So if you have like an equation and you're confused. We can also do ASCII pretty print. I am going to, so I suspect you will never use a computer where this doesn't work. SymPy does predate Unicode support, and what is an example of a Unicode character? See this character right here? I don't really know what that is, right? How about this little critter right here? I don't know what that thing is either, right? And then you definitely don't know what some of these ones at the top are, right? Like, have you ever seen that character before in your life? Like, can I set that equal to 7? No? Maybe? Not allowed? I don't know, right? So those are some pretty goofy characters. So in the olden days, Like back when I was your age. We had to use we only had 255 characters, and we had to share them. So you didn't even get your own 255. Everyone had the same 255. And so when I was 14 or however old you are, this is how I had to look at integrals. And look how uggo that is.
It gets the picture across.
Yeah, but like which one do you like better? Yeah, right. Right. This is Fortnite. This is Minecraft. Right.
Do you play Fortnite?
No, I'm cool. Okay,
Fortnite is cool.
but playing Fortnite isn't
Minecraft
cool.
is cooler, I think.
I don't. Okay, Minecraft is like geeky, right?
Do you play
Okay.
Minecraft?
No, I don't play Minecraft. I gave up video games to run ultra marathons. Okay, like, I don't know what you want me to say. Like someday you'll be 32 and you'll be like, I have no worlds left to conquer, right?
Can't you have the best of both worlds?
You cannot.
Oh.
You can run shorter distances and play video games. The last thing I played was Elden Ring Night Rain,
Oh,
which
yeah.
is like it's for old people, right? They're like, oh, I have time to play a 50-minute session.
I don't have anyone to play Night Rain with.
Oh, you don't play solo? I don't trust normal people.
What?
Well, like so I used to play with other people, and I was like,
Oh.
these people like seem kind of bad at the game.
Yeah.
But like maybe I'm bad at the game. And then I stopped playing with them, and I was like, no, it was not me. Like this is a lot easier. Not to complain about other people. People, the worst.
It's like the best.
I'm just not. I don't really play video games because like I suck at it.
Oh no, you just have to train.
Yeah, I just have to train. But
It's I'm not good at it yet.
Yeah.
Yeah, you have to train for like Elden
But it
Ring.
like
That's-
frustrates me, so I'd rather just lay on, like sit on a sofa and just watch something.
I just went straight from like
Oh my God.
Hollow Knight and the learning.
That's that.
So this is LawTech. Here's the story on LawTech. I went to a math department faculty meeting a while ago, and they were taking their departmental meeting notes in a Google document, and they wanted to express an equation. So they just wrote something that looked like this in the Google Doc, and all of them knew what it meant. So that's how universal LawTech is. Now, I'm not super duper going to teach you LawTech this term, but it is like a pretty big deal. And I think if I just go here, I can drag this over. And it will, that's pretty small. I'll embiggenify. We're embiggenating.
Oh wait, is that why whenever I copied like equations like that from the web and then you paste it on Google Docs, it shows that
Yes.
instead? Because
That's why.
that makes sense.
So like this right here is LawTech styled.
That really makes sense. I guess that's where it came from.
Yeah. See? Okay. Or you don't believe me. Here, let me copy paste some other text. So we'll do.
No, I believe you.
Or you believe me. Maybe I haven't demonstrated this adequately. I don't know. I pressed a bunch of buttons, none of them good. Okay. So, okay. I have some text. Hello. I am copying that text. Control-Shift-C, Control-Shift-V. Okay? It's putting the hello in again. Okay? I am going to highlight this text. Control-C, Control-Shift-V. That's actually crazy. I don't think it was going to do that at all. Okay. Here's how you get LaTeX back. Here's how it shows up on the web. You can throw this directly in Markdown.
Oh, cool.
And I heard the sound of you not believing me, so your homework is to put this in Markdown. See you next time. Don't work too hard. Work just hard enough. I am, in fact, going to make you do this next time. Because I'm fun.
Actually, Elden Ring. Did you play the first Elden Ring? Like,
Yeah.
Which one's
DLC.
better?
But
Yeah.
if I really haven't
Henry?
had, like that.
The second one doesn't work.
Here, hold on. Maybe I can find.
Oh, yeah.
Are they